Hey guys, welcome back to my channel. In the previous video, we completed till question number 7 of exercise 13A, OP Malhotra's textbook for ISC Mathematics. Today we'll be completing the exercise by solving question number 8, 9, 10, 11, 12 and 13 and 14. So let's begin. Guys, so the 8th question is sin raised to 6x plus cos raised to 6x upon sin square x cos square x. So there are quite a few tricky steps involved in this, so be sure to watch carefully. First of all, I'm going to be writing it as sin square x cube plus cos square x cube. So now we can see that this has come in the form of a cube plus b cube upon sin square x cos square x. So we know that a cube plus b cube is a plus b, a square plus b square minus ab. So that's exactly how we're going to write this. We're going to write it as sin square x plus cos square x, sin square x here also. So this is the square of the square because it's a square. So sin square square, which is sin raised to 4 plus cos raised to 4. AB would be sin square x cos square x. Don't have space. Upon sin square x cos square x. Now the next step, cos square x becomes 1. So 1 into, now here we can see minus sin square x cos square x, and we can see sin raised to 4 and cos raised to 4. So I'm going to simplify that by writing this as sin square x plus cos square x the whole square. This would give me sin raised to 4x plus cos raised to 4x plus 2 sin square x cos square x. But here we need minus sin square x cos square x. So I'm going to be writing it like minus 3 sin square x cos square x. So that when this gets expanded and it comes out as 1 plus 2 sin square x cos square x. So plus 2 minus 3 would ultimately give me minus sin square x cos square x upon sin square x cos square x. Now I'm going to write this sin square x as 1. So now I have 1 minus 3 sin square x cos square x. See how that got simplified? Now I can take these as two separate terms. Be 1 upon sin square x cos square x minus 3 sin square x cos square x by sin square x cos square x dx. These are the two separate terms. Now normally I would write this as sin 2x by 2 the whole square, but I'll show you a different method now. Substituting that 1 as sin square x plus cos square x upon sin square x cos square x. That minus 3 into sin square x cos square x upon sin square x cos square x, this thing here, these two get cancelled and we are left with only 3. So I can write only 3 over here dx. Now I'm going to write these two as two separate terms, sin square x by sin square x cos square x. Wow, that's a lot of sin square and cos square. Plus cos square x upon sin square x cos square x. Now because I've written these two as different fractions altogether, I can cut this sin square x in this fraction and I can cut the cos square x in this fraction because they're two separate fractions. Here I couldn't directly cut it because there was a plus sign in between and this was just one fraction. So now this is 1 by cos square x, which I can write as sec square x, and this is 1 by sin square x, which I can write as cosec square x minus 3. Now we know that the integral for sec square x is tan x, and integral for positive cosec square x is minus cot x, and minus 3 into 1, so that 1 gets turned into x, minus 3x, because when we differentiate this thing becomes only minus 3. The 1 gets replaced with, the x gets replaced with 1. So because we have 1 here, we substitute that with x. That's the integration. And here, minus cot, the differentiation for cot is minus cos x square. So the minus and minus will get cancelled and we'll be having plus cos x square x. And tan x, the differentiation of that is sec square x. So plus c, don't forget the plus c, and this is the final answer, which is the integration of sine raised to 6x. This is quite an important question, so be sure to watch carefully and understand what I'm doing. So you can do it in two ways. You can either write sine square the whole thing raised to cube, or sine cube the whole thing raised to square. 3x is 3 sine x minus 4 sine cube x. Now I'm going to take 4 sine cube this to this side. 3 sine x minus sine 3x. So sine cube x is 3 sine x minus sine 3x by 4. So that's what I'm going to substitute in the integral. Here sine raised to 6 can be written as sine cube x the whole square. Now I'm going to substitute sine cube with 3 sine x minus sine 3x by 4 the whole square, right here. A minus b the whole square, which is a square plus b square, 3x, minus 2ab, so 2 into 3 6 sine x sine 3x upon 4 square is 16. Now I can take 1 by 16 outside as a constant, and I'm left with the integral of 9 sine square x. So sine square I'll substitute. I can write 1 minus cos 2x by 2. This is sine square x, we know that. Plus sine square 3x. So I'll write sine square 3x as 1 minus cos the double of that, which is 6x upon 2. Minus 6 sine x sine 3x dx. So as we can see here in the 10th one, sine x sine y is half cos x minus y minus cos x plus y. So I'm going to write that down. Here our y is 3x. So sine x sine 3x is equal to half of cos x minus 3x minus cos x plus 3x. Now we know that cos, the negative, it doesn't have negative angles. So if I get minus 2x, it's cos angle, so it will automatically become positive. So I won't have to write cos minus 2x. I'll just write cos 2x. Because that's the rule for cos, that the negative becomes positive. So half of cos 2x minus cos 4x. Now let's simplify this. 3 separate terms. So 1 by 16 I'll take here. 9 by 2 integral of 1 minus cos 2x. Now the next integral plus 1 by 2. I'm just taking this 2 outside. Here also I took the 2 outside, 1 by 2. Integral of 1 minus cos 6x. And here minus 6 sin x sin 3x. So I have minus 6, and this 2 outside I can take 1 by 2. So I'll take this here, 6 by 2. Integral of this cos 2x minus cos 4x. Okay, so now that we have 1 by 2 common, for each term in the bracket, I can take 1 by 2 outside the bracket as common. So that will become 1 by 16 into 2. And now I have 3 separate integrals with 3 different constants outside. 9 integral of 1 minus cos 2x plus 1 by 2, plus 1, so I don't need to write that 1. Integral of 1 minus cos 6x minus 6 integral of cos 2x minus cos 4x. Okay, so now I'm going to start integrating these three. So this becomes 1 by 32. This is 9 and the integral of 1 is x. Minus cos 2x becomes minus sine 2x by 2. Plus this 1 becomes x. Minus cos 6x becomes minus sine 6x by 6. 6 is the coefficient of x, so you have to take that in the denominator. Then minus 6 cos 2x becomes sine 2x by 2. Minus cos 4x becomes minus sine 4x by 4. So now let's simplify all this. Write as it is. Now 9x, I'm multiplying the constant with the elements of the bracket. Minus 9 sine 2x by 2 plus x minus sine 6x by 6 minus, so this will get cut, the 6 becomes 3 because I'm dividing 6 by 2, so minus 3 sine 2x minus minus becomes plus, and this becomes 3 by 2 because 6 by 4 is 3 by 2 sine 4x. Okay, 1 by 32 here. 9x plus x is 10x. Minus 9 by 2 sine 2x and minus 3 sine 2x, which is nothing but minus 6 by 2 sine 2x. So minus 9 minus 6 becomes minus 15. So minus 15 by 2 sine 2x. So basically I shouldn't have simplified it here. I should have just kept it like that, 6 by 2, because then 9 by 2 and 6 by 2 we can easily add. Okay, then we have minus sine 6x by 6 plus 3 by 2 sine 4x, and the final answer you have to add plus c, and this is the final answer as it is in the textbook. You can see right here, this one. Okay, this was a long question, but it wasn't that hard once you know what you have to do exactly. Okay, so let's move on to the 10th question. The rest of the questions are relatively shorter and simpler. So the 10th question is the integral of tan inverse sine 2x upon 1 plus cos 2x. So we don't have like proper integrals for inverse as of now. So what we are going to do is just simplify this whole thing, and it will actually turn out to be quite simple. So let me just write it as it is, tan inverse. Now sine 2x we know it's sine x, 2 sine x cos x, and 1 plus cos 2x is 2 cos square x. So this 2 and 2 gets cut, this cos and cos gets cut, and we are left with sine x by cos x, which is nothing but tan x. So tan inverse of tan x, so because tan is getting multiplied by its inverse, they get cut and we're ultimately left with only x. So now you only have to integrate x. So see how that becomes so simple. This entire term just gets turned into x. So x dx, now we know that in integration, if you have x, then you have to do the integration. The answer would be the power plus 1. So n plus 1 upon n plus 1. So here the power is 1. So the answer would be 1 plus x raised to 1 plus 1 upon 1 plus 1, which is x squared by 2. Because ultimately when you differentiate this, you get 2x by 2. The 2 and 2 gets cancelled and you're left with x. So the final answer is x squared by 2 plus c. Be sure to comment down below if I'm going too fast or if I'm not clear, and then I'll definitely work on that. So let's move on to the 11th question. Integration of cos inverse 1 minus tan square x upon 1 plus tan square x. Read that cos 2x is equal to 1 minus tan square x upon 1 plus tan square x. So this is what we are going to replace here to make this entire thing simpler. So cos inverse of cos 2x. So now again the cos is getting cut by its inverse. So you're ultimately left with 2x. And 2x, now again we're going to just apply what we learned here, x n plus 1, x raised to n plus 1 upon n plus 1. So 2 into x raised to 1 plus 1 upon 1 plus 1, which is 2 into x square by 2. The 2 and 2 gets cut and we are left with x square. And we know that the differentiation of x square is 2x. So the final answer is x square plus c. Moving on to the 12th question. So the 12th question is integral of cos inverse sine x. Now as we've learned in inverse trigonometry, we ultimately want it to become simpler. So what we are going to do is we're going to try to bring a cos over here. Now we know that sine x is cos 90 minus x. So that's what we're going to replace here. Cos inverse. Now 90 I'm going to write it as pi by 2. 90 is nothing but pi by 2 radians. So this is 90 degrees. So 90 degrees is equal to pi by 2. So cos inverse of cos pi by 2 minus x. So the cos and cos gets cut because this is inverse. So the inverse is just ultimately leaves us with the angle, which is integral of pi by 2 minus x. So pi by 2 is a constant. So to integrate that, we just have to multiply it with x. So pi x by 2, and the integration of x is x squared by 2 like we just did. So minus x squared by 2 plus c. This is the final answer. Today, question number 13. If f dash x is equal to 3x square minus 2x cube, we have to find fx. If f of 1 is equal to 0. So basically this is the differentiation of the function. So to find fx, we have to integrate this entire function. So fx will be equal to the integral of 3x square minus 2x cube dx. Now again we're going to use x raised to n plus 1 by n plus 1. So x raised to 2 plus 1 by 2 plus 1. So that would become x3 into x cube by 3, and the 3 and 3 will get cancelled, and we know that the differentiation of x cube is 3x square. So that's how we got that. Now minus 2 integration of 1 by x cube. Now we can write that as x cube minus 2. We can just take this to the numerator, x raised to minus 3 minus 2. This becomes minus 3 plus 1 upon minus 3 plus 1, which is equal to minus 3 plus 1 is minus 2. Hit the same thing here, and this will get cut. So we get x cube plus x raised to minus 2 is 1 upon x squared. So this is the function f of x. And the reason why we have this given to us, f of 1 is 0, so that we can substitute the value of x and find c, and then find the entire function. So let's just do that. F of 1 is 1 cube plus 1 by 1 square plus c, which is equal to 0. So this is 1 plus 1 plus c is 0. So c is equal to minus 2, which is why f of x is x cube plus 1 by x square minus 2. This is the function. Guys, last question for today. The 14th one, f dash x is equal to a sine x plus b cos x. F dash 0 is equal to 4. F0 is equal to 3. And f of pi by 2 is equal to 5. So find fx. So first of all, let's just substitute this 0 over here. F dash 0. So a sine 0 is 0. So a into 0 is 0, of course. Plus b cos 0. Cos 0 is 1. So this is only b, because it's b into 1. Okay, so now let's find out f of x. So we integrate this entire thing. Integral of a sine x plus b cos x. Now the integral of sine x is minus cos x. So a minus a cos x, integral of cos x is sin x, so plus b sin x plus c. This is f of x. Now let's substitute f0. So f of 0, which is equal to minus a cos x, so cos 0 is 1. So minus a into 1 is minus a. Sin x, which is sin 0, is 0. So b into 0 is 0. So we are left with minus a plus c, which we know is equal to 3. Now f of pi by 2, minus a into cos of 90. Cos 90 is 0. So minus a into 0 is 0. B into sin 90. Sin 90 is 1. So b into 1. B plus c is equal to, what we are given is 5. Okay, so let's just find out the values of a and b here. At f dash 0 is 4, which means that b is equal to 4. Now 4 plus c is equal to 5. So c is equal to 1. Minus a plus c is equal to 3. So minus a is equal to 3 minus 1, which is 2. So a is minus 2. So f of x, which is, here we have minus a cos x. So minus of minus 2 is 2. So 2 cos x plus b sin x. We have b as 4. So plus 4 sin x. We got c as 1. So plus 1. And this is the final answer as given in the textbook. Okay guys, so we have officially completed exercise 13A. In the next video, we will go on to exercise 13B. So see you then guys. Thank you so much for watching. Bye.